what we're going to talk about tonight is basically last years I think I I had this project. So I built a magic wand, tongkat ajaib yang dipowered oleh AI, powered by AI. So basically we run um, machine learning inference on the device, on the microcontroller, using TensorFlow Lite for microcontroller, TF Lite for microcontroller. So um, we're going to do something similar tonight, but with latest trend or latest technology that we have around, tiny machine learning, TinyML. So this live streaming will be unscripted. So the reason I'm doing this because if I record this video, uh, it could be it will take quite some time for me to prepare and everything. So let's go unscripted and let's have some fun. By that you can see my way of thinking and also how how I do things and how I solve the problem live. So it's going to be a long video I think. So stay tuned. Right. So again, last year I did this and I had this writing on Hexter.io. Okay, so basically again, essentially you can recognize the gesture of the magic wand, and I had also a video. I made a video on YouTube. So
using Arduino Nano 33 BLE sense. I attach it to a stick, and this is the whole wand. I'm start. This will show the gesture prediction.
I did some kind of gesture.
Now let's try the first gesture. Wingardium Leviosa. Right. The red LED will light up. Now second gesture is Obliviate. Green LED will light up. Let's try the previous gestures. Wingardium Leviosa. Okay. Red light again. And now the last gesture is Lumos.
And another thing is that I recognize also
blue LED.
something like L.
Hey, Merry Christmas and Happy New Year.
So that's about it.
Thanks for watching, guys.
This,
Goodbye.
This project or with this the way that we made this project. So as you can see it, that if you are Potterhead or a Harry Potter fan, right? As you can see that W is not really Wingardium Leviosa, right? So it's so it's wrong. Actually, it's a wrong gesture. I mean, it's wrong movement for Wingardium Leviosa. So apologize for that, right? So I'm not that into Harry Potter, but so I look it up and basically it's wrong gesture, wrong movement for Wingardium Leviosa and also Lumos. So why is that? Because basically this project is based on a sample code from TensorFlow Lite for microcontroller, as you can see here on this GitHub page. There's a project called Magic Wand that you know, basically they have collected the data set for the, you know, W ring and also slope, something like L movement. They already collect the data sets, and they already also build the model for machine learning model for that. So obviously you can change that. You can collect your own data set, and you can train the model by yourself. There's a model training mechanism that you can follow up. Jadi teman-teman bisa ikuti ya script atau cara untuk training gesture recognition ini dari page ini gitu ya. You can use it for prepare the dataset, and you can use it for splitting the dataset, and also for training itself. Of course, you can do that, right? So, but it will involve some works, obviously, and for the early or beginner in machine learning, this could be cumbersome. Ya, cukup akan cukup susah ya untuk ngikutin ini. So that's the first concern for this. And another thing is that because as you can see that I'm using a development board called Arduino Nano 33 BLE Sense. So initially this, although right now it already have Arduino sample code, but initially they had, but the way they orientate, I mean the orientation of the development board for, you know, for the code that within this the sample is not right actually. So, you know, I have to do some modification for that. So I actually I think it's my own GitHub. So this one, right? So this is my sample code, my code, right? So I had to do some kind of reorientation of the I have to do some kind of code modification to be able to orientate the development in the correct orientation, right? And to do the gesture, you have to do, I mean, the orientation of the board has to be like this, right? So the I have the one here. Ini tongkatnya, ya. Teman-teman bisa lihat. Jadi menghadap apa ya, orientasi dari boardnya harus seperti ini. So the orientation has to be like this, right? Has to be like on the video. So when you go upside down, for example, the recognition will be failed. So that's not quite flexible, right? So I think we can do something about that. Yeah, so what we are going to do tonight is we're going to use a tools. We call it Edge Impulse. For you guys to, you can follow it along later. Basically, we can use it for, you know, collect our own gesture, our own data set, and we can use it for, you know, building the model, the machine learning model, and we can use it also for speed up the testing on the real device, right? Okay. So the reason I'm using Edge Impulse, obviously, because recently I was appointed as officially as Edge Impulse ambassador, the first one from Indonesia. So I'm I had, and I'm willing to talk about that, to talk about this technology. It's very, very interesting technology, very awesome technology, as you can see later. Um, I think I can show you the yeah, this is the email from Adam Benson, uh, CXO of H Impulse. So basically, I'm obviously onboarding as one of the ambassador. So I'm thrilled to talk about this technology. So before we move forward to see how we can leverage H Impulse to to build our machine learning model and to do magic wand gesture recognition easily, obviously. So I think you should know what is H impulse actually is, right? Jadi apa itu H impulse ya? Jadi teman-teman perlu tahu dulu nih apa itu H impulse. I think the best way uh, to explain what is H impulse.
Impulse provides the embedded machine learning development
From H impulse CEO Zach Selby. So let's hear from him directly from this video.
billion devices used by 3 million developers by 2030. Edge Impulse provides the embedded machine learning development platform in the cloud. We're enabling developers and engineers to make use of this new technology and, starting with the actual embedded devices, gather sensor data from their products, from their environments, turn that into useful data sets, and use those data sets with algorithms.
Mungkin yang kurang paham ya, saya coba jelaskan dalam bahasa Indonesia. Jadi pada dasarnya Edge Impulse ini adalah platform di cloud ya. Ya pada dasarnya tools yang teman-teman bisa lihat di cloud, bisa gunakan di cloud ya untuk mentrain machine learning. Oke. Jadi machine learning yang ditujukan khusus untuk embedded devices ya, untuk microcontroller, untuk ultra low power microcontroller especially. Jadi tools di cloud, teman-teman cukup buka browser ya, bikin account, habis itu udah langsung bisa pakai gitu ya. Jadi kita bisa gunakan untuk mengcollect dataset, mentrain ya, lalu memvalidasi, mencoba performance dari model yang sudah kita train tadi. Dan yang paling penting juga adalah mendeploy. Mendeploy artinya bagaimana model yang udah kita create itu kita deploy ke device, real device ya. Dalam hal ini misalnya ya kayak ini Nano 33 BLI ini. Ini salah satu challenge juga gitu, karena biasanya bikin model machine learning itu cukup it's one thing ya. Saya nggak bilang itu gampang, tapi it's one thing. Begitu kita udah beres, misalnya let's say kita dapat model dalam bentuk TensorFlow Lite gitu ya. Nah, bagaimana itu bisa di deploy, artinya di install dalam tanda kutip ya, di flash ke real device gitu ya, ke hardware-nya. Nah, itu masalah lain gitu, dan itu cukup rumit juga gitu ya. Dan kita harus punya inference engine-nya juga gitu ya. Inference engine artinya code yang actually membaca input lalu melakukan inference ya, melakukan prediksi, melakukan pengenalan dan seterusnya berdasarkan model yang udah kita buat sebelumnya. Nah, itu sebenarnya nggak sangat tidak mudah gitu ya. So Edge Impulse itu bisa end to end ya, untuk mengakomodasi life cycle dari development machine learning ya, khususnya untuk embedded devices ya, untuk microcontroller. So that's the idea of Edge Impulse, right? Alright, so again ya, tujuan kita adalah menggunakan tools ini ya, instead of kita coding semuanya sendiri gitu ya, dari mulai training sampai validation atau ini ya, validate our tiny machine learning performance, all the way to deployment and also inference right on the device. Instead of we code all the way end to end, we can use Edge Impulse to as a tool again, as a tool for us to speed up development. So let's see what is. Kita lihat ya, kalau misalnya apa namanya, dimana kita bisa nemuin Edge Impulse ya, you can go to this website ya, edgeimpulse.com ya. Tentunya teman-teman harus daftar ya, kalau belum login ya daftar. Terus kita bisa lihat dokumentasi di sini. Oke, di sini kita bisa baca ya, how we can get started. Lalu misalnya yang out of the box development boards or development kit yang out of the box supported obviously by OS Impulse. Kita bisa lihat di sini ya. You can see here there's a the one from ST Micro, and also this one Arduino BLE Nano 33 BLE, and also the one from Himax and IT Compute. And the latest, I think one of the latest is OpenMP Cam. This one is obviously important for object recognition or object classification. I mean visually using camera and everything. So these are the official boards from they're supported by Edge Impulse right now. But if your board is not yet supported, you can port by yourself. Yeah. But it's not that easy actually, because Edge Impulse Inference Engine, they depend on DSP, digital signal processing component within the microcontroller. So if your microcontroller doesn't have DSP, that's obviously will be challenged to port this SDK. I hope they will support ESP32 very soon. I hope that. I will propose to them, obviously, because ESP32 is, I think, one of the most maker-friendly and most well-known microcontroller platform. So there has to be, I mean, they have to support that, right? So to get started, obviously you need to have development board. You need to have microcontroller that support it. Most of this microcontroller is basically ARM based, ya, jadi berbasis ARM until now, at least. And right after that, you can go to studio edgeimpulse.com, and you can create new project from here. So let's see, we can create a project called Magic 1. Okay. So as a note that I have not tried this, right? So I did play around to collect the gesture data. I mean, just a gesture like Lumos and everything. But I have not built the model itself, so I don't know whether it's it's going to work or not. I mean, I think so. I think it will work. It will work, right? But yeah, we'll see about that. So let's go to this project that we just created. Oke, jadi kita sudah punya projectnya. Nah, pertama yang harus kita lakukan, so the first thing that we need to do is we connect the device, right? So we connect a device that supported by H-Impulse. Again, for now, I'm going to use this Nano 33 BLE. Okay. So how we can get this device connected to this studio, right? So that the first question. So the way we do that, we can go to this documentation. It's basically you need to have you need to install some kind of prerequisites or dependencies. First of all, you have to install the Node.js. So I think I have already. Okay, I have Node.js version 12. And you need to have Arduino CLI. I think I also have this Arduino CLI. Okay. And then you need to install H-Impulse CLI. Okay, I already installed that. H-Impulse CLI package. Basically, these are the executable or runtime that you need to have installed in your development computer. Okay, right. Then after that, you need to connect the development board to your PC. Okay, I just connect that, and we can confirm by LCSP. Okay, as you can see that this is the Nano 33 BLE, so it's already connected. And after that, you need to flash the latest firmware for Arduino 33 BLE. You need to flash the latest firmware in order to collect the data and to do inference and everything. Okay, so you can download that, and okay, so as you can see in this zip file, you will have the command, the shell script that you can execute to flash the firmware. So this is the actual firmware. Okay, so as long as you have installed all the prerequisites, jadi kalau teman-teman udah install semua syaratnya ya, semua requirement softwarenya, kayak tadi apa, Arduino CLI, udah install Node.js gitu ya, most likely ini akan jalan dengan sukses ya. So for Mac OS, obviously you need to call +mac.command, but if you're using Windows or Linux, you call respective shell script. Okay, so as you can see that the script will flash the firmware to Arduino Nano 33 BLE. Oke, jadi kalau berhasil nanti teman-teman bisa langsung run H impulse daemon atau H impulse run impulse. Ini nanti kita pakai ya. For now we can use this one, H impulse daemon. Okay. So first thing first, we need to clear if previously you already connect this, this development board to a specific project. You need to clear first. Sorry, I think clean, right? I think clean is not clear. Okay, right. So dash clean. Sorry for that. So by using this parameters, you basically clean your local setting, and you specify the new project that you want to connect this development kit into. So since we are going to connect to this project, which is Magic Wand, ya, jadi kita ingin connect ke project Magic Wand ini ya. Jadi di sini kita akan login dengan account H-Impulse kita and specify the password. Oke. Nah, dari sini kita lihat, from here we can see the list of project that you can connect this device to. Jadi kita tadi mau connect ke Magic Wand. Nah, terus kita mau kasih nama apa? What the name that you want to give to this device? So for example, Nano 33 BLE. Oke. It's success dan harusnya nongol di sini langsung ya. Jadi kalau lihat teman-teman lihat di sini langsung muncul Nano 33 BLE. Jadi kalau tadi namanya apa di sini akan munculnya sesuai dengan yang kita ketik di sini. Oke. Nah, sekarang kita siap meng-acquire data ya. We are ready to do some data acquisition. Alright. So let's go ahead and do that. Nah, kita kan pengen tadi apa? Mengenali gerakan tongkat ya. Misalnya gerakan apa tadi? Wingardium. Ya. Wingardium Leviosa. So we want to be able to recognize Wingardium movement, right? So obviously we need to collect the movement data, and later we need to train that movement to this machine learning model, right? So first thing first, you need to make sure if you have more than one device, you need to make sure that what device you want to collect the data from, and the sensor that we will use, obviously a accelerometer. Basically, accelerometer is a sensor to measure the acceleration of the movement. Nah, kalau teman-teman ingin misalnya membuat apa ya, speech recognition atau keyword detection, so we collect the data from microphone obviously. Right. Nah, dan yang kedua adalah yang perlu kita set adalah sample length. Jadi berapa lama kita mensampling datanya gitu. So how long the data we want to sample in millisecond obviously, and the frequency of the accelerometer. So 100 hertz or 92.5 hertz. So let's stick to 100 hertz. Pastinya lebih besar frekuensi lebih baik ya. Cuman ya nanti biasanya lebih banyak makan power gitu. Oke. Sebelum saya start sampling, mari kita lihat dulu Wingardium Leviosa itu kayak gimana gerakannya. Saya juga nggak apal-apal terus. Movement. Oke. Nah, menurut gambar ini, nah ini kan contohnya. Jadi Wingardium Leviosa tuh kayak gini. Nah, jadi ini ya. Jadi bentuknya kayak gini. Oke. Nah, kalau dilihat dari gambar ini ya, so if we see this pattern or this movement pattern, I think it will take some time to from the start to finish ya. Dari awal sampai selesai movement itu akan perlu sekian detik gitu. Jadi kita harus ini juga gitu, harus bisa memprediksi ini kira-kira satu gerakan ini perlu waktu berapa lama gitu. Nah, ini nanti berpengaruhnya kepada sampling length ini, sample length ini gitu. Oke, jadi misalnya coba ya kalau kita coba misalnya gerakan itu tadi kan gini ya, gitu ya. Ini mungkin 1, 2, 3 gitu ya. Jadi mungkin sekitar 3 detik ya. So if we do the movement, I believe it will take about 3 seconds. So let's set the sample length to be 3 seconds. Okay. Okay. Let's do some arrangement here. Nah, jadi yang pengen saya tunjukin adalah ketika kita ingin mulai mensampel data, ya, we just click this start sampling, and this program we call it Edge Impulse Daemon. So Edge Impulse Daemon will will listen some the command from the dashboard from the studio, and it will start to actually collect or read the data from the accelerometers on this dev kit. So let's see, if we click start sample, as you can see there's an incoming sampling request and the sample started. Okay, so obviously if we do nothing, I mean if we don't do any kind of movement here on the hardware, so you can see that this is the actual data that collected from the accelerometers, right? So it's not right actually, so let's delete that. Let's do another sampling. Okay, Wingardium Leviosa, right? Okay, now as you can see that if we do that movement, there's some pattern here, right? Okay, let's do another sampling. Wingardium Leviosa. I think it's too early. Yeah, sorry for that. I think it's too early. Oke. Oke, kalau teman-teman lihat ya, di situ udah mulai kelihatan ya. Di sini ada polanya gitu. Ada 3 gelombang, ada 3 peak. There's a 3 peak on this waveform. Okay, let's keep sampling. Okay. Dan seterusnya ya. Jadi teman-teman harus collect datanya sebanyak mungkin ya. According to Edge Impulse, they suggest the data about 10 minutes for all label. So as you can see that we currently only have 1 label. So if we have, for example, 4 label, 4 gesture for pattern that we want to recognize, then we need to collect about 2.5 minutes each, right? So the total will be 10 minutes. So another way you can do is that you can sample the longer length. I mean kita sample lebih lama ya. Misalnya let's say 30 detik. And during this 30 seconds we can do the movement. We keep doing it. I mean we can keep doing the movement, and later on we can split the data. Okay, so let's do that. So I have 30 seconds. I will do several movement of Wingardium. Okay. Nah, hati-hati nih begitu kita bergerak kembali ke titik asal. We need to be very careful for that. Supaya gerakan kembali ke titik asal ini tidak dianggap sebagai gesture gitu. Okay. Nah, so as you can see here, we have 30 seconds of data, but it's obviously it's not all valid, right? It's not all data is valid. So we need to split the sample. Okay. Nah, karena kita tadi punya 3 detik ya data yang sebelumnya, we have 3000 millisecond. So we set the segment for that 3000 millisecond. So as you can see that we can split the data here. I think this one is not really good. This one as well. This is okay. This one is too much noise. So from this 30 second we can have 4 data. Okay. Okay, jadi kita udah punya sekarang 21 second ya, in total of data. Right. So let's do another movement. Lumos. Okay. Nah, honestly, I'm quite confused with Lumos movement. There's some version that basically Lumos just doing the flick up, yeah. But there's another version that basically you move circular counterclockwise, something like that, right? I believe I have this video. Where is it? Let's see. Lumos movement 1, something like that. This one.
Now, Knox is the counter spell, which is just done by a flick. Lumos is the wand lightning charm, and it's made by doing a counterclockwise twist. Now, Knox.
So let's follow that up. I believe something like counterclockwise. Okay, something like that. Alright, so let's do that. Let's do first for 3 seconds. Okay. As you can see, there's a significant difference between Wingardium and Lumos. Kelihatan ya bedanya ya. Di sini ada 3 puncak, di sini ada 2 puncak. Okay, let's see. Let's do another. Okay, mirip lah. Okay. Alright. So another thing that if you remember in the when I explained earlier that my previous project, this one, is not really flexible in terms of the orientation orientation of the hardware, right? So if you do, you know, this and then you do that, right, the gesture will be failed, right? I mean it's not that flexible. So so that the gesture will be flexible, you need to collect from all orientation, right? So initially we do some the orientation this, and then we need to do this kind of orientation, and then later something like that and something like that. Okay, so let's do that. So let's do this orientation. To Lumos. Okay. And you can, kita bisa bervariasi dengan tangan kiri misalnya, karena tangan kanan tangan kiri biasanya suka beda. So you can do various with right hand and left hand, and it would be better if you do collect from another person instead of just yourself, ya. Jadi dari orang lain juga di collectnya, nggak cuma kalian aja. Okay, now let's do this orientation. Oke. Okay. Nah ini kan kelihatannya bedanya ya. Ada yang merah, biru dan hijau ya. Jadi beda yang menjadi puncaknya itu merah, biru atau hijau gitu. Tergantung orientasi dari boardnya. So depend on the orientation of the board, the peak the axis, x, y, or z axis that will be the peak will be different. Okay. Right. Let's see another. All right. So that Lumos, and the last gesture that we want to recognize is Knox. So Lumos is to turn on the light, and Knox basically to turn off the light. So based on this image, Knox basically just click down. Then I think this guy also
is the counter spell, which is just done by a flick.
So let's do that. Knox. Like that, right? So that Knox. Okay, obviously there's a significant difference between Knox and Lumos. Okay, let's do another thing. Okay, let's do another. All right. So you know, we can do all the way up to several minutes. And the last thing that I want to collect is idle. So idle, basically we don't do nothing. We do nothing. I mean, we don't move the board or the magic wand. So we just put it on the desk basically. So let's collect as many seconds as we want. Do we still live? Oke, kita masih live ya. What about YouTube? Okay. All right, so bentar ya, saya mau make sure kita masih live atau enggak. Alright. Okay, kita udah collect idle, so we have collect the idle label. Nah, ya kita harus mengkolek terus datanya gitu ya, tapi it will obviously will take some time, so to collect the necessary amount of data. So for that I already collect before, as I said that I already play around with the data collecting for this for this data set. So right now I want to do a demo for how you can import the data that you already collect before, or the data that you can get from somewhere, your college or somewhere else. So to do that, you have few options. Let's see. Okay, this one. So to import existing data, basically you can go to the upload data and go to the uploader. Okay, so the format of the data that you can import is a CBOR. I'm not sure what's the CBOR itself, but it's basically JSON, and then the JSON is not it's not text format, but is in binary format. So I already have that. Let's see which. Okay, I think this one. So I already have that. So the data will be like something like this. So this is the training data, and this is testing data. So as you can see, that this is CBOR format. If you look at the content, basically you cannot really see the content because it's a binary. Okay, I think I need to turn off the notification. So basically this is the binary format, right? So CBOR is binary. By that I think it's the data size will be quite small. Alright, so let's import that. So over here we have training data, so we can open all 19 files, and for this you can choose whether this is the training data or it will be automatically split between the training and testing data. Obviously we are importing the training data right now, and the label itself you can ask the studio to infer to check from the file name, which is, as you can see, this the file name contain the label itself. Okay, so you can begin upload. So uploading 19 files, and okay, it's done. Okay, let's see. So yeah, So as you can see that the we already successfully import the data, I believe. Yeah. Also, you can check that how long for each level the data is. So for example, this for the Wingardium level we have 1 minute. For Knox we have 1 minute 49 seconds and everything. So obviously the data has to be balanced for each levels. So as you can see that idle basically not is still not the same as other levels. So let's collect for another data for idle. So it's about 30 seconds, right? So let's collect 30 seconds, 30,000 milliseconds. So I want to highlight that for idle. So basically, when we do, you know, when we do gestures or movement, for example, Wingardium, something like this, right? So that we can repeat to other, we can do another movement, or we can repeat the same gesture. So basically, you need your wand have to be at the starting position, right? So this movement, I mean, when you want to go back to initial position, something like this has to be recognized as idle as well, right? Because this kind some kind of movement is not really idle, but you don't want this movement recognized as one of the three labels that we want to recognize, right? So let's classify this one as idle as well. Okay. So let's do start sampling. Okay, so I do this back and forth. So this movement has to be idle, has to be classified as idle. Oke, jadi ini harus diklasifikasikan, dikategorikan sebagai idle supaya nanti ketika kita ingin kembali ke titik awal dari gerakan-gerakan kita itu tidak machine learningnya nggak bingung gitu bahwa ini nanti dikiranya apa gitu, ya kan? Oke. Nah, kalau kita lihat ya di sini tetap ada semacam gerakan ya. So that's some kind of movement, but it's not that obvious. It's not that really quite the same as another movement. Okay. So you not really sure, we can sample the data so that we can ignore this kind of transition. Okay. Probably something like this, and this. So this up and down will not interfere our data. Okay. So there you have it. So idle, we still have. We need to collect another 20 seconds. So let's do standstill, something like this. So this also should be categorized as idle. So don't do sudden movement. Okay. All right. So there you have it, 20 seconds of idle. So as you can see from this chart, there's not much of movement there as well. Okay, I think we have balanced data set. It's about 1 minute 50 seconds. Okay, now we can start to do the impulse design, but for first thing first, we need to also import the test data, because the test data and training data has to be different. The test data is basically the data that never seen during the training process. So let's also import this from the data that we already collected. Testing. Okay, let's collect all that. I forget to set this as a testing. Sorry for that. I hope. Damn. Okay, I think we mixed the data. Too bad. Okay. Apparently we don't have the data. So let's delete that data first. I think during this one, right? I think this is the data that we just imported. So let's delete that. Okay, let's repeat the process. Now make sure that we upload into category testing category, info from file name. Okay. Okay. All right. So we have the test data right now. We have. Okay, I think we need to split this up so that we have a correct 2-second segment. This one's not okay. Okay, this one is Knox. Okay, Knox. All right. So we split that into several Knox movement. Let's do another for Wingardium. Okay. Split that. And another thing is for Lumos. Sorry. Split. Okay, split. Alright, so as you can see that we have idle, Wingardium 20 second, 15 second, 12 second. Yeah. So for the testing data, I believe it's not really important to be balanced, because we only use it for testing later. Okay, so the most important is for the training data. All right, let's do impulse design. So to be able to pick up the pattern of the data that we have, of the data set that we have, so obviously we have time series data right now. The data is coming from the accelerometer, which is axis X, Y, and Z. And the first thing that we need to choose or need to specify is that what is the window size of the data. Obviously we have 3 seconds of the data. Okay, let's make sure we have 3 seconds. And as for window increase is the overlapping between each segment or each window, which is between for each 3 seconds. What's the duration of the overlapping? Jadi dari window 3 detik, 3 detik, 3 detik, kita pengen data apa namanya nanti pembacaan data itu akan bergerak setiap berapa lama gitu ya, dan overlappingnya itu kira-kira berapa lama. Yeah. So we can choose whatever we want. So I will choose about something like twice as that. Okay. So obviously this one has to be a trial and error, right? So I'm not sure whether there's some kind of rule of thumb for that. Maybe I don't know, but yeah. Okay, so that's for the time series data. Another thing is that we need to add some kind of processing block. So processing block is basically the initial the block of within the pipeline of your data. There has to be some kind of processing, right? So for example, you need to analyze the spectral of your data, right? So for example, you want to extract the power and the frequency of the data. So obviously, because we have time series data, when you do some kind of this movement, there's some frequency, right, of the repetition of your movement, and also the power. I mean the peak and everything. So by that, the latter process will be more flexible in terms of the orientation and everything of the board. So that's why we need to add some kind of spectral analysis. Okay. Then after that, after the data has been initially processed, then you obviously need to have some kind of learning block. This block is actually doing the machine learning, right? So for now, since we have the time series data, we want to use neural network using Keras. Okay, and as you can see that the input picture will be the output from the previous block, which is spectral analysis block, and the output will be the label that we have already defined. Alright, so save the impulse. Oke, jadi saya ulangi ya, kita punya processing block ya untuk memproses awal data yang masuk, data dari accelerometer, dari input accelerometer aksis X, Y, Z itu nanti kita dalam pipeline ini kita akan hitung berapa frekuensi, berapa power, apa istilahnya root mean square-nya dan seterusnya gitu ya. Nah output dari situ nanti akan kita feeding ke machine learning, neural network gitu ya, yang dibangun dengan Keras, dan outputnya adalah label yang tadi kita udah define sebelumnya. Okay, now we specify the spectral features that we want to process. Okay, let's see, for example, the Lumos movement. The first thing that we can do is apply some kind of filtering, which is usually we use low pass filter. So low pass filter will obviously, as the name is, will filter the lower frequency. So when you do movement, obviously you will have some kind of jittering, right? Jadi akan ada getar-getar kayak gini. Nah biasanya getaran-getaran seperti ini nggak penting gitu, ini noise. So kita harus filter data seperti itu. Makanya kita lakukan namanya low pass filter, gitu ya. I'm not sure what's the other settings, but if we do change, for example, cutoff frequency, for example, we change to 2, the the result of the waveform after the filtering will be quite different, right? So 2 and 3 will be different. So depend on the intense. I mean the pattern that you want to pick up. Depend on that. Depend on your data. That's what I'm trying to say. So for the FFT, fast Fourier transform, this basically for converting the data bit from the time domain into frequency domain. So by that you can get what's the frequency of the movement, right, of the data coming from accelerometers. So as you can see, for this is the frequency is quite low, as less than one hertz. So let's see for another data, for example, Wingardium. So as you can see that we have about 1 hertz of frequency. We can play around with the FFT bin length, right? So for example, if you do something like this, the result will be different, right? Okay, let's use this because okay, so because if you only use 128, the frequency is not there. So let's stick to 256. Let's set that. Okay, let's check whether we still live. All right. Okay, now we move forward to generate the features for the data. So let's click that. So for the 6 minute 51 seconds of data with the 3 seconds window length and 160 increase of the window, you can see what kind of feature that we able to pick up. Wow, this is quite something. Okay, as you can see that the picture can be separated bit quite okay between Knox and Lumos, and also some of the idle, but there's some idle here is not that kind of mix up between idle and Wingardium, right? So this could be the problem. It could be a problem later, I think. Okay, we can click on one point, I think, here, the idle data that quite near with the Wingardium. Let's click that. Okay, I think it's not right? I think the data is mixed up. Okay, let's check that. I think the data is mixed up. Yeah, obviously. Obviously this is not idle. So that's why, I mean, you need to be sure that okay, I know it. I think the problem is that I need to split this up. Okay, I need to split up to 3 seconds of the sample length, right? So you cannot just import the data from existing data set without take a look the actual data. It will create some problem later on. Okay, so we need to split it up. So let's see the data for example 20 seconds. We need to split. Okay, this one is okay. Split. Oops. Okay, this one is not okay. Yeah, let's remove that. Okay, this just one thing to note, that basically this whole process has to be iterative, right? You cannot just get the right, right process in one go, right? So you cannot just collect and then go to the impulse design and everything, do the training, and you directly get the right and good model performance. It's not the way it works. Obviously you need to be iterative for that. So that's why I do this as live streaming, because you can see the actual process, right? It's not something that prescripted or already prepared before, right? Because that's easy. Okay. Let's do for Wingardium. Okay, I think it's okay. Let's do for Knox. I think this one is quite noisy. Let's move that. This one as well. This one is quite noisy. Let's remove that. Right. This one is, I think it's, let's move to this one. Okay. Obviously it will take some time. Bear with me. Okay, a few more. Lumos. This, okay. Okay, let's check on idle. We need to be sure that there's no surprise here. What about this? Okay, that's okay. It's not really okay, so let's split that. Just this one. Okay, one last thing is Lumos. one. This last thing. Right. Okay, so we have split all of data. Okay, so we can check that the data is quite balanced. So let's collect for more for the idle. It's about 40 seconds. So basically, currently I hold the stick to be quite, as still as possible. Maybe doing some minor movement so that this will be classified as idle. So, right. Okay, let's crop that data. So besides splitting, you can also doing some kind of cropping. Okay. Right, this one has to be. All right, so it's not quite balanced there. So what you can do is that you can do some kind of rebalancing the data set. To do that, you go to dashboard, you go to danger zone, and what you can do is you can do rebalance data set, and you do rebalance, data set. Okay. So by now I think you already have the quite balance, right? I'm not sure why its idle is longer, but it should be 1 minute. Okay. Anyway, let's try to do the again to do the spectral picture. Okay, let's generate the picture again to see whether we can get the proper separation between each label. So this is the previous data, right, that we have. So let's generate pictures again. I hope right now we can see that there's a better separation. All right. So as you can see that we already have quite okay separation between the red one, which is Wingardium, the orange one, this is the Lumos, the idle is about this, and Knox is up on this green side. So I think this is quite okay. All right, so for that we can go ahead and to do the training, to do the neural network training. So all right, so to do that, first is that you need to specify how many training cycles or epoch that you want to do the training for this neural network. And obviously there's no magic number as well. You can try and error, and also the learning rate, and also the minimum confidence between each level, so that it can be classified as that, right, as that specific level. Ya, jadi training ini bisa berapa aja gitu ya. Tentunya makin banyak makin baik, tapi tidak selalu gitu ya. Tidak selalu begitu, karena nanti ketika terlalu banyak biasanya tidak ada improvement lagi ya dalam hal performance machine learning ya. Jadi kita nggak ngabisin waktu sebenarnya kalau terlalu banyak. Ya. Begitupun learning rate ini juga bisa berapa aja ya, bisa 0,001, bisa 0,005. Ini tergantung nanti seberapa perkembangan peningkatan ininya, apa namanya, akurasi dan seterusnya gitu ya. Nanti kita bisa lihat dari hasil training ya. Okay, for now let's use the default value here. Let's do the start training. Okay, the training is done. As you can see that the accuracy is about 99% and the validation loss, the loss is about 0.08, but the validation is important. It's still quite some value. Obviously the lowest validation loss is the best, the better. Right, from the confusion matrix you can see that the model will be able to correctly classify as idle 100%, and Lumos as well, but there will be confusion between Knox, Lumos, and idle, right? It's actually very bad, right? It's actually bad. So the Knox has to be, the confusion is okay, but obviously for this case Knox has to be, much bigger than this percentage. Okay, so one thing you can do is you increase the number of training. Let's see, let's put 100 there and do another training. Okay, honestly I'm starving. Allow me to smoke. Don't try this at home. Okay. Right, so it's better, right? So you can see that the validation loss is now much smaller. Previously I believe it's about 1.1 0.1, now is 0.02, right? And the accuracy is quite high, but don't get excited yet, because there's a case of generalization here, when the model is very good as remembering or memorizing the data. Jadi jangan terlalu senang ya kalau misalnya validation loss dan validation accuracy ini, validation lossnya kecil banget, terus validation accuracy-nya gede banget gitu ya. Itu belum tentu ya sebenarnya, belum tentu bagus, karena bisa jadi model yang kita bikin ini mengingat gitu, karena dari datanya yang ada itu dia ngelihat data yang ada terus dia ingat gitu. Nah yang paling benar nanti adalah ketika kita lakukan validasi terhadap data testing tadi ya, test data. Okay, I think this is okay for now. You can play around with the number of the neural network architecture. So for example, if you add another layer here, usually the deeper or the more layer, usually the better. Not quite always like that, but the problem is that when you add more layer, the model size will be bigger, right? So bigger model size will cause more more memory to be consumed, more RAM to be consumed, which is quite limited in the embedded devices. But let's put another layer here, and let's train again. kita juga bisa ngelihat ya, kalau misalnya di sini validation loss-nya nggak berubah ya, jadi misalnya tadi 0,6, 0,6, 0,5, berarti ini kan masih turun ya, berarti masih oke. Tiba-tiba kalau dia nggak turun malah naik gitu, nah itu artinya uh, tidak ada peningkatan gitu dalam hal performance modelnya. Jadi kita bisa jadi salah ya, bisa jadi trainingnya nggak perlu 100 gitu, nggak perlu 100 kali evoke-nya, atau bisa jadi learning rate-nya yang salah gitu. Jadi kita bisa lihat, kita bisa judge dari penurunan dari loss atau kenaikan dari akurasi itu. Okay, I'm not sure there's much different. Actually, I forgot the previous number. What's the previous number actually for this confusion? I'm not sure, but I'm not sure it's much different than previous architecture of the model, right? As you can notice that when you add more layer, the ROM usage will be bigger, right? So previously I believe it's about 13k, now it's about 15k, right? So let's remove that again. Let's do another training. So remember this right now is 15.6k of ROM or storage that will be used later on the real device. So if we remove again the dense layer that we just added, we can see the difference, right? Okay, let's see. Job completed, and now yeah, as you can see, I think that's no different at all, right? So let's stick to this architecture for now. Okay, so right now what you can do is actually to do the model testing, right? So from the test data that you already prepared, we can use the data to classify. So this data is never seen by the model. So this is the real testing, right, for the performance of the model. So we classify all the data. Right. It's quite okay. So as you can see that using the unseen data or test data, so the accuracy will be 91%, which is quite okay. So only two data that's not really certain. So for example, this has to be Knox, but the prediction is idle, right? So another thing is Lumos. This is uncertain. Uncertain means that the probability is low, right, to be considered as valid prediction. All right, let's try this model to the real device. Okay, that's what we came for. So to do that, what we can do is to do the deployment. Okay, so as you can see from the deployment tab here, you can deploy the model as a library, which means that you develop your own firmware, but you use library that generated from Impulse, right? So the library will contain everything that you need, the model, the SDK, and everything. Or you can, for the testing purpose, you can just build the firmware and you can just flash or burn to the real device, right? So this, for now, for this for current live streaming, we will test directly on device by building the firmware, so we can speed up the testing process. Later on, we can try to integrate the library that is generated by Impulse to our own application, our own firmware. Okay, sounds good. Okay, let's click this. One thing to note here, there's a optimization here. This is optional, but you can activate the Ion compiler that recently released by Impulse. Okay, you can activate or deactivate. As you can see that if I turn off the Ion compiler, the RAM usage, the memory usage will be higher. Okay, so obviously this is very good optimization, obviously. But latency is similar, and also the ROM usage also bigger when you turn off the compiler, the Ion compiler optimization. Ya, jadi ini penting ya. Kalau misalnya dinyalain, maka akan terjadi optimisasi terhadap penggunaan RAM dan penggunaan ROM-nya atau storage ya. So obviously let's turn it on. Ya, jadi kita nyalakan aja. Coba kita analyze optimization-nya. Apakah ada perubahan ya? By the way, we can select the the classifier to be quantize. Quantize meaning you compress the data to be in integer instead of float number. Or you can stick to the unoptimized, which is still using the float, float number. And as you can see that there's not much different, right? Whether you use quantize or you use unoptimized, the confusion matrix will be quite, I think, actually the same, right? So obviously we select the quantized version of the model. Right. So now we built the firmware for our testing purpose on the real device, and based on my experience, it will take sometimes, actually quite sometimes. So while we're waiting, let's do live classification. Okay, so using live classification, basically we can sample the data from the real device, and then the model will try to predict, the model that we just created will try to classify the data. I mean the gesture that we perform. Okay. For example, let's see 10-second data. Let's do some motion. For example, hey, why is not starting? Okay. Okay, basically I'm not doing anything, right? So as you can see, the data is about this, right? So it's quite flat. So this is the prediction, right? So the prediction will be idle. So most of the data is idle, which is right? All right. So let's do another. All right. Lumos. Okay. So I hope we can get Lumos prediction. Okay. So initially it's idle, obviously, but then it correctly from this waveform, I think we can see that the prediction is right. It's Lumos, right? It's Lumos. And this is not actually right. Then Lumos again. Then idle over here. And then over here, then we get Lumos again. All right. So I think it's performed well. Okay. right? So the nice thing about H-Impulse that the testing data, I mean the live classification data that we just collect, is basically will go to the test data over here. Okay, so this is the testing data that we just collected, right, from the live classification. So from this data, we can, we can use it for training as well. Yeah, we can use it for training again in next time around. Okay. So yeah, we can do the split and everything just like before. So for example, this is idle, so I need to crop the data, so I can ignore this part, and then I change the label to be idle, right? I can even change the name of the file so that it's not confusing. Idle, right? And as for this one, we can do the splitting. This is Lumos, right? So let's this has to be a way to do multi label renaming, but I'm not sure how. Right. So now we already consider the data that we just collected from lab classification to be used as test data or training data, right? Okay, let's get back to our, okay, so the previous firmware building is finished. This is the file. Let's use it. Okay, this is the firmware. As you can see that there's a firmware file, firmware.eno.bin, and this is the command. Okay, let's try that. Let's try let okay. So okay, cd, where am I? Okay, cd magic. Okay, so flash Mac. Now we are flashing the binary, the firmware, to the actual board. Okay. Now we can just try in order to try the actual prediction, we need to run what is called impulse runner. Impulse runner. Right. Okay. So as you can see, if I do nothing, I mean the board the stick is basically just stay still. If I do stay still, then as you can see, the prediction is idle, right? This idle. Let's see. Let's do some kind of Knox movement. So it's important that you do the movement right after the sampling has been started, right? Knox. Okay, as you can see that Knox is 98%. Let's do another Knox. Okay, I think I'm wrong. Knox. Okay, it's tried to classify as Knox. Let's do another Wingardium Leviosa. Wait a minute. Wingardium Leviosa. You need to correctly spell that, right? Not Leviosa, but Leviosa. Okay. Let's start another. Wingardium Leviosa. Okay, I think I missed the window. Leviosa. Right. So again, Wingardium 99%. Let's do Lumos. Okay, Lumos. Okay, Lumos 99%. Lumos. All right. Lumos. All right. Knox. 94%. Wingardium Leviosa. Okay, I think I missed the window. Let's see another. Okay, 87% Wingardium. So as you can see, guys, that our model performed quite well. I think it's performed very good actually. So we don't have to do another, training and optimization. So we can just use it as it is. So in next live streaming, I will show you how you can deploy this model as library, so that you can integrate this library, the model, into your own or your existing firmware or existing application. So this is just half of the journey, because obviously we don't want for the user to wait for the sampling to start, right? Because obviously for example, if this is the real product or end product, you don't have some kind of mechanism to give the feedback to the user, right? You cannot tell that when to start to do the movement, obviously. So there has to be some kind of continuous recognition or continuous motion recognition. So for that kind of application, I think you need to build your own, obviously. And for example, if when a certain gesture is detected, then you want to do something, right? For example, if you do probably you do Lumos, then I don't know, maybe you want to turn on the light, your room light, for example. And when you do Knox, then you want to turn off the light. Yeah, obviously you can do that, right? So for that, you need to deploy the impulse, the model as library, right? So that you can integrate to your own application. So that's for now. I'm starving, and it's quite late here. So thanks for watching. See you again soon. Sorry for very slow demo. I hope you can get the idea of that. Basically, during the development of machine learning application, it has to be iteration. It's not one go process. So I hope you can see that that's actually the real process behind that. All right, see you again, guys. Thank you. Bye.